Welcome to 1803 ICT and 7610 ICT Introduction to Information Systems. So this is Lecture 1, Introduction to Information Systems, so the IS part, and then Human Activity Systems, which is the HAS or the HAS part. And we'll see these acronyms many times throughout the course. So teaching staff for this course, it's me, Sven. I am available by email, and email is preferred, so s.venom@griffith.edu.au. I have a phone number, but probably it is unlikely that you will get me by phone because I'm not necessarily near my phone. So email is definitely preferred. And Nathan Campus N44 2.21 is my office. I should update that. And Logan, it's L08 2.09. Let me just update that now. 2.21. There we go. And we talked about the assessments already. There's 4 workshop exercises, 5% each, so 20% total. They're due in weeks 3, 5, 7, and 9. They're marked in the workshop, so you must attend your workshop. And the preparation for those is done the week before, so weeks 2, 4, 6, and 8. So as long as you follow that preparation, you'll be well prepared for the actual assessment part. The major assignment is 50% due in week 9. The workshop prepare you for the assignment. Final exam is 30%. And then in the workshops, we'll talk through the actual process for these things. The textbook is Business Information Systems by Bain and Davies, 2nd edition. There's an e-book version that you can access, and it's probably worthwhile reading this textbook. It has a lot more detail and information than we're going to be able to cover in the lectures, for example. So they give more context and so on behind some of the stuff. So just in terms of looking at this course, we have a variety of people in the course. So we have undergraduate, postgraduate. We have IT students, we have business students. There's a whole bunch of different groups of people who are doing this course. And so it appeals to a lot of different people from different backgrounds. And so the course is not about technology at all, right? In fact, we don't care about technology at all. We don't care that we have computers that do certain things, they have to be programmed a certain way. It's not important at this level. What we do care about is that we have computers. Right, that we can rely on them, that they'll be there and we can use them to do processing for us. Does that make sense? So that may be a very different perspective than some of the other courses you may have done, right? Because a lot of those courses are technical and they're really looking at, well, how does a computer work, or how do you write a program for this thing, right? So that's not what this course is about. So what we're looking at is no programming or anything like that. We're looking at, in terms of a business, how do we support a business to be more competitive? There are a number of ways to do that, and the way we're looking at that is through this information systems lens. So in the course, you are going to be a service provider and not a developer, right? So a developer makes things, builds the software. You will be the person who provides the service. It's a different perspective. So looking at an IT department, so an IT department has to provide some value. And so the course is about providing a service to the client. And if the IT department doesn't provide the value to the business, what do you think is going to happen to it? Will the business keep a department that isn't making money or is costing them money? No, at least they'll restructure it. They'll do something about it. And they may actually outsource it, right? Because it's cheaper or more efficient or effective to do that. So in terms of being in an IT department, you have to demonstrate value. And that may not necessarily have been the way that you've looked at an IT service department or IT department previously. Right? They have a role to do. They might service the machines. They might provide software for whatever. But actually what they're doing is they're providing value in some sense. Right? That means that the business will be able to operate more effectively. So information systems, the field, as a field of academic study, is made up a number of independent or interdependent topic areas. And there's a bunch of them around the outside there. So I'll go to the drawing slide in a second, but just read through the content here for now. So those areas overlap with other disciplines, and those other disciplines provide the academic frames of reference. So there's 2 slides involved here. So I'll show you the first one first. You'll see here that one obvious one is technology. It's an obvious area. Development or making these things, these systems, is another area. The organization, right, also has an influence. The management of this or these systems also has an influence. And then the environment that you're in. And if you're looking in the middle here, this is where they all intersect, right? So They all influence this middle part, which is the thing we're talking about, the information systems part at the moment. So here are the academic disciplines that are related to those. So same diagram, just with more bubbles. Right? So if you're looking here, the technology. Well, who does with the work with technology? Computer science, typically. That's maybe changing depending on the kind of technology you're looking at. Maybe it's data science or cybersecurity or those kinds of flavors. But there is some scientific underpinning for those things. They're developing those tools. So development, this is actually building the system or the software and so on. And there are life cycles and processes for these. And typically we refer to that as the discipline of software engineering. Okay, making robust software basically. Organization, well, there's a lot of theories about organizational behavior and so on, so we can draw on those academic influences. Management, do you think there's a lot of stuff going on about management in terms of theories and whatever? Yeah, so again, there's a whole big discipline we can draw on from there. And then the environment, sociology, politics, economics. Now, typically we don't talk a lot about those in the technical courses. Right, in the technical courses, where are we? We're in this space. So in some sense, you can see where they all meet here, that information systems draws on a lot more stuff. It brings in a lot more academic disciplines, right? Which in some sense makes it a lot more complex. Right? There's a lot more that you might need to know to be able to have a conversation around these things. Does that kind of make sense? Okay. So those were the reference disciplines. Now you see there's a bunch of them. There might be more of those, but these are just sort of the key ones that you can relate to based on this diagram. Okay, so one thing that you'll notice in this course is there are a lot of diagrams. And part of that is diagrams or models convey a lot of information very quickly. So this diagram, once we understand it, will tell us a lot of information that I could spend probably 3 pages writing text about, right? And still it might be a little bit vague about exactly what's going on. Does that make sense to you guys too? Right? So one of the things that you'll see is a lot of these models. So this has simplified some complex information. We'll talk about that later too. So in this particular example, we've got an organization at the top there with those round sort of cylinder kind of shapes, and they're connected in some way. So those cylinders there are human activity systems, and there's one sort of zoomed out of, and there's a human activity system which has, some more little boxes in it. Now, the term human activity system, what does that suggest to you? Are there people involved? Yeah, they're humans doing stuff, right? So it's kind of a fancy term for people getting together to do some stuff, whatever that happens to be. Now, ideally in an organization, they're working towards the organization's goals, right? That's why they're employed. Now, they're supported there, or they're connected by an information system, and an information system has some components in it as well. That information system is connected and supported by an ICT or some kind of technology system, a server or some kind of computer that does some processing. So we can link these in a number of different ways. So that diagram kind of shows you as a picture what's going on. Let me draw it slightly differently. I think I'll just use blue. Yes. So we'll just use a different color, I think. So basically what we have at the bottom here is the ICT stuff. And you'll see that it's connected to the information system. And it's connected because the ICT serves or provides stuff to this system. So that's their connection. Connection could go backwards as well, but typically we just use this thing to process stuff to give us information that we can use, right? And so above that, there's a human activity system. And the human activity system needs information to be able to function effectively. Okay, if you want to get people together to do something, they have to be able to make decisions. How are they going to make decisions? They need information. Where does the information come from? In this case, it comes from some technology, right? It could be a sensor, it could be a server, it could be any kind of technology. And then eventually, this human activity system, what does it do? It contributes to the organization. So we can say the ICT serves the information system supports the human activity system, and together the human activity systems make up an organization. They comprise the organization, because an organization is basically people doing stuff, right? Okay, so that's another way to look at this same diagram. It's a different way to model it. Now, the one on the right might be easier to follow. Does that make sense? Okay, it depends. It depends on the context for the thing. So, some information systems are automated. They run on this ICT technology. Again, we don't really care about the ICT stuff. We just care that it's there. We can use it. But it doesn't have to be automated. And you'll find lots of systems that actually are not automated. So an example, we'll come back to, I think, later on as well, is on my desk, I have a bunch of post-it notes, all right, which I write down stuff on based on what I need to do soon, so I remember it. Is that an information system? Yeah, absolutely. It's got information on it, right? And I can use it to process it. Is it very efficient? For a few notes, it's pretty good. Once I get more than 10 post-it notes, it's going to become very difficult to manage that. So actually, it's not a very efficient process in the large, but in the small, it's really good. It's probably actually more efficient than my using my phone as an organizer, right? Because it's just easy to write on a piece of paper, and I can stick it somewhere, and I can just keep it there. Yeah. So there's some trade-offs there. So what I'm saying here is everything does not have to be automated. Now, for the course, we're a technology course. We're going to look at the automated versions, but that's not necessarily the best solution in some instances. So we've got an organization. Let's say the organization is Griffith University. Let's give a concrete example, because that's pretty abstract, right? So Griffith University. Human activity system. Well, we're in one at the moment. What are we experiencing right now? Boredom? No. What is this that we're doing? It's a lecture, right? So it's a human activity system. It's comprised of people doing stuff. There are some rules governing how it operates, right? Is it different from a workshop? Yeah, absolutely. Like, there's different rules around how we engage in this environment. Is there an information system that supports this activity? Yes. How did you get here? There's a web page which you have your timetable on, most likely. There was an enrollment system before that you used to get that enrollment organized. There's a Learning at Griffith course website which has information about the lecture content. There's a number of these systems that you actually just use all the time. Again, you may not think of them in that sense, but they're supporting this activity. They support other activities too, by the way, but this example, that's one they're doing. And is there any ICT stuff underneath those systems? Sure, there's a bunch of servers, databases, right? Lots of things that together allow those systems to operate. Okay, so that's kind of how this maps. Yeah. Could they use a filing cabinet for this? If they had one person enrolled, probably, but for 100 people, not anymore, right? You need something automated. Okay. So we can also, what I've done there basically is we're going from the top to the bottom, from the organization down to the ICT in the first diagram, and now I've gone from the bottom up, right? From the ICT up towards the organization. I think probably for us, it's easier to view it from the bottom up. Yeah, it just seems to make a little bit more sense in terms of how they connect to each other, but either model is okay. So the focus of this course is basically the human activity systems and the things around that, right? So again, definitely not technology based in that sense. So human activity systems, they're also called business processes. Okay, so that's a slightly less human sounding name. And so a human activity system, or a HAS, H-A-S, comprises a logical collection of activities performed by some groups of people. Okay, so we get together as a group and we do something, and it has an outcome of some kind. And because we're in a business context, that outcome should relate to what the business needs to be done. Okay, and if we support that, the business does better. If we don't support it, the business does worse. Okay, and probably there'll be some evaluation about whether we're doing a good or a bad job. So organizations can be conceived of as chains of human activity systems, and those activity systems are associated with the production and dissemination of value. And you'll see this term value showing up all over the place because it's really important. Now, value comes in different flavors. So we can have products or services. They can be tangible or intangible. So, for example, some companies may spend money sponsoring certain things. Now, they don't get anything back directly for that, but they may get goodwill from, the population in terms of supporting their company. Right? So that's a cost, but again, it creates value in some intangible sense. It's not a product that they're delivering, but they can get some value back from it potentially. Another example down the bottom here is a student borrowing a book from a library is a human activity system supported by many information systems and also some ICT or some technology. And the value of that system is getting the book, right? There are a lot of books out there. If you want to find a particular book, is that easy or difficult? Well, you can make it more easy by having an appropriate information system. Right? Imagine if the library had all these books and they had no database. So you'd have to go to the library and you go, I want this book, and they say, well, look, there's all the books, go and find it. Would that be efficient or effective? No. Right? So these systems enable people to get better value out of these experiences, I guess. And so the value is located in getting the book, and we'll use some of these examples and we'll sort of analyze them a little bit as we go through too. So information is important for the coordination of human activity to meet established goals. So we need some systems that assist us in gathering, processing, distributing, and using that information. These things are the information systems. They support some human activity. They can be both manual or automated. I gave some examples of a manual post-it note kind of system just before. And Blackboard or Learning at Griffith is automated. Filing cabinet is manual, and it's really useful for certain things, but it doesn't scale well, right? So a lot of the systems that we interact with, they need to scale well to multiple users or many users. Okay, so post-it notes also don't scale well. So while we're here, why don't we have a quick talk about the assignment? So again, I told you before, the assignment is about, let's say, Amazon Australia as a supplier of products. Now, the reason it's that is, it could be any company really, but I think we're all pretty familiar with that particular company, right? So previous assignments have been an airport or the Commonwealth Games, for example, when it was done at the Gold Coast, a hospital. So reasonably large organizations. And the reason it has to be reasonably large is that it has some opportunities for human activity systems. Do you think that Amazon has a lot of human activity systems? Yeah, there's lots of different things they do. So it should be fairly easy to find something to work with in that space in terms of doing an assignment around it. So the human activity system could be anything, right? And so it could be as simple as, okay, look, Amazon has a headquarters somewhere. They have a parking area. How do we coordinate parking at their headquarters? Now, that's a little bit trivial in terms of the company's a lot more interesting than that. But certainly, do you think they would have an information system around that? They could do. If you go shopping these days, you go to a shopping center and you want to park your car in the car park. Is there an information system that helps you, guides you where you can park, where you can't park? Yeah, there's little numbers that say there's 8 spaces over here, there's no spaces over there. So things are becoming more automated in that sense. So that's a low-level kind of system that you could have a look at. Do they have a payment system, do you think? Sure. Do they have a dispatching system? Yeah, do they deal with delivery companies? Absolutely. They have a data center somewhere, or a couple of them, right? So there's a whole bunch of things that you could rope into this in terms of analyzing a system, in terms of the assignment aspect. So just have a think about that, and you'll be asked to think about that in the workshop as well. So the organization for the assignment will be the same for everyone, but there's so much scope that no 2 assignments should be the same, right? Because they're all, you can choose pretty much anything. And even if you do choose the same thing, your solution will be different, right? Because you think differently and you would have scoped it slightly differently. So the nice thing about that is you get to choose something that you're interested in, and that company is big enough that there's lots of options to choose from, right? Once you've done that, now one of the nice things about this kind of process is you end up with a report for the assignment, right? So if your assignment is pretty good, then you can use that as evidence for when you're, going for a job somewhere, and you can use it in an e-portfolio or something, because it's a formal written report, right? It's an actual an outcome from a process. So some other examples of these human activity systems. This is really important, so we'll talk about a few different versions of it. Um, take some mundane things. So how did you get here? Who caught public transport? A few people, right? So is there an information system around that? Yeah. Okay. Is there an organization around that that coordinates that? Yeah. So you can see how you can slot these things in, right? Um, on the campus, if you didn't catch public transport and you drove here, is there security checking that you have the appropriate parking permits and whatever? Yeah, that you parked in the right spaces. So there's other systems around it. Library we talked about, enrollment, so you've already gone through those. The main thing here is the value. So each of those things provides some kind of value. If it didn't, then the organization most likely would not be doing it, or they would not exist. So I guess while we're here, it's probably a good time. I'll just illustrate that with this diagram. So this thing down the bottom, this ICT, provides some value or something of value to the information system, which provides something of value to the human activity system, which provides something of value to the organization, and finally the organization, to survive, has to provide value to the outside world, the clients or the customers, right? So you can see it's a value chain. You start with a little bit and you basically make it more valuable as you go up the process. We will see quite a bit about that that process as we go through. So let's talk about the ICT stuff. So this is my favorite stuff, but we've got one slide on it. And really, it's really important, right? We need this kind of technology to be able to support all these activities higher up. But it doesn't matter what the technology is, actually. Right? If I'm working with other people, as long as I've got a thing that supports what I'm doing, that's all I need to know. So the ICT provides a means of constructing aspects of information systems. It's distinct from the information systems themselves, and it's not the focus of the course, so we can kind of ignore it, which is kind of nice, right? It gets rid of a lot of the technical details that are interesting, but not necessarily appropriate when you're talking about the human activity system itself, right? So let's have a look at the relationship between the different systems that we've talked about so far. So we have an organization on the outside, and there's some actions. I'll get back to that in a minute. There's a human activity system in the middle there, so the yellow sort of part. Then there's an information system, and the information system provides information to the humans. So the humans make decisions. Those decisions result in actions. So I kind of waited with the actions part until we got the reason why they're taking the actions. And then there is some ICT, or some technology, which supports the information, or the creation of the information. So typically we don't get information straight up. We get some data, and then we process it to get information out of that. Meaning, right? So if I tell you I've got some information, typically that means I've done some kind of processing on that. Data would be something like 10. 10 on its own is meaningless, right? You need to look at the context to see what it means. If it's 10 ice creams, then if I have 10 ice creams, do I have too many ice creams? Yeah, I can't carry them all, right? So depending on the context, the information has been processed and you can get some meaning from it. But this is the overall scheme of things. So you can see organization, there's actions happening. Who is making the actions happen? The human activity system. Why are they taking those actions, or why are they doing those actions? Because they made some decisions. How did they make the decisions? There was information they got in, and the data supported that information. If the information system is successful, then our decisions will be better, and our actions will be better. If the information system is not very successful, then we will make poor decisions, and the business will suffer as a whole. Right? So, all right. So an organization is a series of interdependent activity systems which in combined action produce value. And I sort of indicated that with that diagram with the sequence of things. So value is the key flow between an organization and actors in its environment. So businesses deliver this value through products or services provided to customers. We already talked before here about, from an IT perspective, we are now going away from the products, the technology, but more to the services, right? And businesses, they have inputs, so they receive value from suppliers or partners. So sometimes they start from the ground up, but sometimes they take something that's already been processed in some way and then they do something with it. You'll see the example at the end of this lecture where we talk about galvanizing some steel, which is just a kind of random example, but it illustrates a number of different things related to what we're talking about at the moment, and they get some inputs in. Those inputs already have probably had some value added, right, because they've been processed in some way. Okay, so a business organization is a value-creating system which interacts with a wider value network making up its environment. Okay, so this is a diagram that's kind of showing a little bit of that, and we're going to talk through these as we go. We'll add a little bit to this as we go through. So at the moment, we just see the organization and the activity system. There's an external actor, and the external actor could be a person, it could be a company, and you'll see that there is some exchange of value between those. So let's make this a little bit less abstract, because it seems pretty abstract at the moment, right? Let's go back to the Griffith University model. So Griffith University is the organization, the blue box. The human activity system, or the activity system, so the textbook will just use the words activity system, but probably interpret it as human activity system. That activity system somehow relates to an external actor. Now in this case, Griffith University, we're using a lecture as the example. There are people in here. Now apparently, you're getting value from me. Yes? That's what this diagram says. I hope that's the case. On the other hand, you are providing value to the university in some way. And so, for example, it's tuition fees, right, that you've provided the university get this experience. Does that kind of make sense? So the value can be different depending on the environment, but there will be some kind of exchange. So organizations require these activity systems to function because they're the things that get things done. So human activity systems in turn rely on information systems. We already seen this in a slightly different format. So an information system is a system of communication between a group of people to coordinate the action of those individuals. And you'll see there now we've added decisions and information in terms of those flows. They're just arrows. We've seen this diagram before, right? Slightly different version of it. But now the external actors involved here as well. So information is data interpreted in some context. A datum, or a unit of data, is one or more symbols or things that is used to represent something. So an example of this is pretty formal kind of language, but if you're talking about the number 10, we have some symbols to represent that number, right? A 1 and a 0. Does that make sense? Right? So there's symbols that represent certain things. So on the basis of information supplied by the information system, decisions are made about appropriate actions to take. So now we're talking about data and information. We'll spend a whole or half a lecture on this actually later on, what some of the issues around this are. I'll give you an example, I guess, at this point. This human activity system has to make decisions. Now it needs information to do that, and we already talked about information. It's not the first stage. Data is the first stage. You have to process it. So I'm going to give you an example. I think it's an ice cream truck, right? So I've got an ice cream truck, and I want to sell ice creams. Am I going to sell more ice creams in cold weather or hot weather, do you think? Hot weather, most likely, right? Makes sense? That's information. That's processed data. How do we know that? Because our experience tells us that over time, in hot days, right, we would have had more ice creams. Yeah. So as someone who owns this ice cream truck, imagine that I get up in the morning and I look at my ice cream truck and it says, okay, I've got 10 ice creams. Doesn't seem like a lot. Okay. Could be. If it's a cold day, am I going to sell 10 ice creams? Maybe not. Then I listen to the weather report and it says it's going to be really hot tomorrow. Two pieces of data. 10 and hot tomorrow. Can I put those pieces of data together and make some information out of that? Or meaning? Yeah, sure. I can say, look, I've only got 10, it's going to be hot, I don't have enough. Yeah, that's my information that I've gotten from this, or the meaning I've gotten from that data. Might be more data floating around as well. It would be even worse if it's a weekend coming up. It's not just a Monday, for example, right? So that data, when I've processed it, It's given me some information or meaning. With that meaning, what am I going to do? I'm going to make a decision, and the decision will be go buy some more ice creams. Yeah? And the action I will take is go out and buy more ice creams or order more ice creams. You see how they relate to each other? And they're sequential in that sense, right? So if I have a bad system for giving me data, so I took a really quick look in my ice cream truck and I thought, there's 5 or maybe there's 50, right? The better information I have, the better choices I'm going to make because my information is better, right? So that's a really simple example. In terms of putting it back to value, well, why am I doing this? Why do I care if I have 20 ice creams instead of 10? What's it going to do for me if I have more ice creams? I'll make more money. Yeah, I get better value out of it. I'll still make money maybe out of 10, but I'll make a lot more if I have 20 or 100 or whatever it happens to be. All right. So I'm going to use it to improve my position in that sense. So another thing that we can think about here is, in terms of value, have people or businesses been spending a lot of money on IT? What do you think? Absolutely, right? It's pretty impressive what people are putting out there. So has it all been beneficial? No. So some of those things have not done so well, right? So if you spend something as a business and you do not get a return, what do you think happens? You lose resources, which means the business is not as viable as it was before. Okay, and typically what will happen is they'll reevaluate this part of the business and say, well, it's not working. We change it or we get rid of it. Right? In terms of IT, what happens? Outsourcing, potentially, right? They get another vendor to do it for them, right? Or they just decide that's not the area or the approach that we want to take. So IT departments have to justify their existence, actually. Okay, they're expensive. They had better provide a good service that maybe indirectly gives value. It might not actually attract people, but it supports, for example, in the university, that you can actually go to your lectures with the material that you need. And you have access to the workshops, the assessments, and all that kind of stuff. If that wasn't done to a particular level, the university would probably lose money. Right? That makes sense? Because people wouldn't be able to enroll or get the service that they're expecting. So the university has a really big IT department. That means it's very expensive, right? So to justify its existence, it has to do a lot of different things. It has to provide a lot of different services at a fairly high level, right, to support that. And so what they're doing is they're providing value to the university, and the university says, great, you're providing value to us, we will pay you. That's the value they get back. You can see how it's kind of cyclical, right? So in terms of, as a customer, you, in this lecture, what does the university provide to you? Education. Now it's a nebulous thing, right? Ideally it's targeted so that what you want to achieve with this education is going to be possible, right? So you get knowledge, you will get a qualification at some point, okay? And for that, you pay some money, you pay your time, your energy, right? So there's some value that you're contributing. In terms of when you get a job, maybe a different way to look at it, you will provide some value to the company that you work for. And what do they give you in exchange? Money or other incentives, right? So that's another way to look at it. So data can be supplied to the information system by its ICT system. Could come in lots of different ways, but let's say it comes from an ICT system. And one thing that wasn't in this diagram before is that ICT systems between actors or entities or organizations or people, they can talk to each other. So for example, I can use my phone to interact with some of the university services, right? So my ICT system here is talking to the university's ICT system. All right, so they can directly communicate in some sense. So that complicates the diagram a little bit. Information systems also have to be developed. It's a big process. Very difficult if you have a complex system. And so there are other things going on now. It might be getting a bit small to read this part. So let me just jump to the diagram on here. I think it'll be easy to see. This one, you'll see there's some yellow lines now in this green box called Information Systems Development. So that development, it happens in phases or stages, and you'll see there are different life cycle models and so on that you might run into depending on the course you are doing now or have done. You'll definitely see some in the future if you haven't seen any already. So these things have to be developed, and there are a number of stages. So first one is conception, and you'll see conception is in the blue organization box. So typically someone in the management says, look, we need to do this, we need a system to support this. It comes from the top down. Does that make sense? Right? And so that's why it's in that box. You'll see that the next one, which is analysis, is an activity, something you do. So an activity system will be created to do that analysis. Then there is design. Then there is construction, and then implementation. So they seem to make sense, right? You ask for it first, then you think about it, then you build it, and so on. And you'll see that some of these arrows are in different layers because this is where they relate to mostly. We don't talk about the development lifecycle in this course. We sort of mention it, but that's not the focus of this course. There are other courses which will talk about the development lifecycle in much more detail. Right? So you will get more information about that there. But there is a process that people go through. So after an information system is introduced, it begins to have some effects. There is an impact. And I'll point out that if you introduce an information system into an organization, the impact will not be neutral. Right? It will have an impact. You have changed something. So it could be good, it could be bad, but it won't be neutral. There will be some change. And so this one is showing you the little sort of pink arrows at the top there. There are some different levels of effects. So the first order effects are the ones that are issues of use, so they concern people. And the second order effects concern the impact of the information system on the organization as a whole. So if you're looking at this, again, I think I'll just jump to the diagram because it will be a little bit bigger and easier to see. You'll see that there is some evaluation happening over here. Then there's use and impact. Those are the two levels of concern that we talked about. So the use is in the activity system, and the impact is in the organization level. You can see where they're kind of situated because they're different levels of concern. So later on in the course, we will talk more about the impact of information systems, and typically they have a big impact on the people that use them and are exposed to them, right? Because there's a process that you've got to follow to use them. So when you put an information system into a workplace, there is an impact. Not all impacts are good, and even if management, for example, says, look, this is good, the people on the other end who are using the system may have a different perspective. I'll give you a really clear example. Imagine that management says, fine, we've got this process over here, we want to automate it. We're just going to buy some robots, right, and we'll make it automated completely. From the management side, that's great. Save money, ideally. Yep. And what about the people who are doing those jobs at the moment? Is it good for them? Not at all, right? So here's where I think there was a question before about what makes this a little bit different, this kind of information systems topic, is perspective is really important. Right? Depending on whose perspective you take, you will get a different outcome or a different understanding of something. That's particularly important when you're doing the modeling. So that's an extreme case. Other cases might be, well, look, you were using something for a while and then a new system is introduced. Will you be as effective or as efficient immediately as you were with the old system? Probably not, right? It'll take a while to get acclimated to it. And actually the new system may be worse than the old one in some ways. And so maybe it de-skills the person. Now they have less skills. Over time they actually lose skills because they're not doing certain things. If your job has been partly automated, will you feel good about that or bad about that? You could go either way, but probably most people won't find that very, very nice, right? So there was an example. So in terms of this automation things, it does happen. And so there was I think 2016, there was an example with Foxconn. So you know the Apple and Samsung supplier, they supply all those parts. They apparently got rid of 60,000 workers and replaced them with robots in a factory. That's a large-scale change. Right? So that was in the news a couple of years ago. So from the company perspective, that's great for the bottom line, but for those people, that's terrible, right? So there's always a perspective that you should keep in mind. Another thing that you should probably be aware of is that the system will succeed or fail based on how people use it. So if the system isn't doing its job properly, then people may try to work around it or not use it or do other things. It's a really simple example that you probably see around quite a few places. You have these electronic doors, right, with the swipe card kind of access, and they're not always convenient. So what do people do? They put a chair in the door, right, and they leave it open. Does that defeat the purpose of the electronic lock? Sure. So people will find a way to work around things that are not in their interest in that sense. Okay, and that can contribute to the failure of the system. And so human issues are eventually more important than system ones. And system is a failure if people don't use it. And we'll have a little bit of a look towards the end of the course about some system failures, a particular one with an ambulance system, which is a really good case study of things not to do or things to be aware of when you're going to implement a system on a large scale. Some of them seem like common sense, but that doesn't always happen in some of these projects. So from a technology perspective, again, taking the programming kind of side, you're asked to build something. You're given a specification, you build it, it's done. Your job's finished, right? Yep. Now that's not really the case with this perspective, because you've built it. Now what's the impact on the users, the organization? Is it providing the value it should be? Could it be done better? There's a whole lot of questions around it, and that needs some analysis as well. So this figure shows you that there's another stage to this in terms of that information system development. Around that, there needs to be some planning and management. There's no good just building a system. Right? And I think there's plenty of examples where that's been demonstrated not to be very good. You need to have a reason for the system, and it needs to be integrated into the goals of the organization. Right? It has to support that. So planning and management are necessary to ensure that the information systems are successfully aligned with the strategy of the organization. And there are some courses in second and third year, and in the master stream as well, which focus on those things. Are they really important? Yes. Right? You want to make sure you get these things right, because these projects are big and complex and expensive. So business organizations are systems of human activity. They rely on, are supported by systems of information, and they rely on and are supported by technology. So this is just a little quick summary of all the concepts that we came through before. Informatics, or information systems, is a systemic discipline. So informatics is the European term, right? So you might see that term so now and again. It's interested not just in technology or hardware, but in the systems, information, and the organizations, and how they interact and the effects of these things. So it's a slightly broader look in that sense. So now we move on to putting this together as a kind of a modeling exercise. So here's an illustrative case. It's called Goronwy galvanizing. So totally random kind of scenario. So galvanizing is basically taking some steel and coating it with something, so it protects it in some sense. So it's a process, mechanical kind of process. But it's a process that you can model, which is what this is about. So you'll see this diagram. What can you tell me about this diagram? It's pretty busy. Yeah, a few things on the screen there. Are there different shapes? Yeah, so probably the shapes mean different things. And what you'll do is you'll learn about a modeling language or a way to draw some things, and they have rules about how you represent stuff. So this one has particular symbols. I'll just talk to you about this diagram here quickly. You'll see, actually maybe, I'll probably just go to here and just draw on this one. So this is the same diagram, but now I'll just draw on it as, here's a customer, an external entity. They apparently give some stuff to Goronwy galvanizing. Goronwy galvanizing, this is a process. It takes in the inputs and it creates some outputs. So this is input and this is output, and the output has been processed in some way. How has it been processed? Well, they've taken the zinc and the black material, which is the steel that hasn't been galvanized yet. They put them together and they process them. So you end up with some white material, which is the processed stuff, and there's some information, dispatch advice note, whatever that means, right? But there's some kind of information. You see the shape of this thing? It looks like a torn kind of piece of paper. Yeah? So that's what it's meant to represent. So it's information. Then on the other side is a customer. Is this customer on the left the same as the customer on the right? Could be. Doesn't say it has to be. So you might need some more information about this diagram. So just looking at it, you might not get all the information from it. Does that make sense too? But what you do get is a pretty good idea of what the inputs are and then what the output is. Okay? In a very simple diagram, actually. You'll see there's probably quite a lot of text that you would need to describe all this stuff. And when you have text, it's not as easy to work with in the sense of getting an understanding of it. If you wanted to show this to, say, a business owner, would you prefer a diagram or a bunch of text? What do you think? Diagrams probably easier to work with, as long as the modeling tools are simple, like the pictures and so on, they're not too complicated. Because the business owner is unlikely to be an expert in the modeling language that you're using, right? Okay, so this is a context diagram. Just shows you, overall, this is what happens in this environment. It shows only the organization and the external entities, or the users or the customers. So here's some text that describes the same thing. And actually, this has been organized really nicely, but there's still a lot of text. Okay, so the inputs are black products. So they're the products that have not been changed yet. The Rito Metals supply zinc as a raw material for the galvanizing process. They're a key actor. They're important in this process. They're a supplier, actually, in this sense. The outputs consist of these galvanized products. They've had a coating put on them, so they're different from when they started. The transformation in this system is the process of galvanization. The information flow consists of documents detailing deliveries and dispatches, and the physical flow of material comes from someone, gets processed, goes out to someone slightly different. So when we're looking at one of these diagrams, you see all the stuff that's in bold? They're the key things we're looking for. So this has already been processed and organized in that way. Normally, if you were going to build one of these diagrams, you would probably talk to the business owner and you would spend half an hour talking to them about how the operation works, and you would have to tease out all that information and build a model. Does that kind of make sense too? They probably won't give it to you in this nicer format. It'd be nice if they did, but it's unlikely. So there's quite a bit of work, first of all, in pulling out the information, building the model. You would show the model to the person and they'd say, actually, no, that's not quite right. You would adjust it and you eventually work out something that's, appropriate for that context. Okay. So an activity system diagram is a diagram that shows a collection of activities, okay, processes and tasks, and those things are performed by a group of people in pursuit of a goal. This sounds like the human activity system, right? We're kind of modeling what's going on here. So that's a model. Have you heard of models before? Sure. Do we use them fairly frequently? Yep, they're really powerful things, actually. So a model and modeling is something that you'll use quite a lot in this kind of environment. Really simple, I guess, kind of model that you're probably familiar with is when you take a train, right? You see the train diagram? It's a model of the train stations. Is it in any way accurate? It's accurate where the stops are in relation to each other. What about distance? No. What about location? No. They're kind of relative to each other, but they're not. It's not a real map. Yeah, it's a compressed version of this. Is it useful? Yeah, it hides all the information you don't need and gives you exactly the stuff that you do. So it's actually a really good example of a model that provides the information that you need and gets rid of all the extra stuff. So one of the challenges with modeling is getting the right level of what you need and what you can take out. So for Goronwi's activity systems, Goronwi's activity systems are likely to consist of processes for the things that they're going to be doing. So what are they? One of the things was we're going to receive unfinished products. They're the inputs. So we're going to have a process for that, right? Because they're coming to us, we're going to have to deal with them. We have a process for galvanizing, so we're going to have to deal with that. That's going to be a process that we have to model. And when we've finished, we have to send these out to someone, so we have to have a way to deal with that. There's a process related to that. Now, there may be other processes, but just looking at that big context level diagram, they're the three main things you should be able to pick out of that one. Does that make sense? Cool. So in the activity or any activity system, there will be some form of embedded control, some regulation for doing things, some way to adapt to changes in the environment so things are being processed. The regulatory control is implemented through a process called feedback. So basically something happens, and then you can ask a question. Okay, this happened, was it to the level that I expected? And I'll show you an example in a minute. But basically you can measure against some level of performance to see, should I make a change now or not? So we get a decision point. Yes or no, we do this or we don't do this. So here are some human activity system diagram symbols. Some of those will be familiar. So the circle is a customer or an external actor. The square or the rectangle is an activity. There's a diamond there with a condition. This is basically, it looks a little bit like a flowchart if you've ever seen those kinds of things, right? So there's decision points. Something comes in at the top in that diagram, in the diamond there. You ask a question, and the answer is yes or no. And depending on whether the answer is yes or no, you will either do this thing or you'll do this other thing. There is an arrow there with material, and that one is basically just the material flow, a physical thing. And there's some information. It's, like I said, it looks like a piece of paper that's kind of been ripped. Okay. So what we're actually using, let's go back to this slide here, just really quickly. What we're using here is a limited form of BPMN, which is a business process modeling notation. It has a lot more symbols in it. We are deliberately going to restrict the symbols for this course to keep things simple. And you can certainly model everything you need to do in this course with this, not just these symbols, there's a couple more we talk about, but it can get very complicated otherwise. So we try and restrict it as much as we can, and we can still get the job done. So here is the scenario for Goronwy galvanizing. There's a wall of text, and I even separated it out so it wasn't as wally as it could be, right? But it's still quite a lot of text. So what you usually get, you'll get a scenario that's like, if you look at the workshops, there's just a paragraph of stuff that you're going to have to look at and analyze and process. That's normally how this stuff comes. So what I've done, one thing you can do yourself, split it up a bit, make it a bit easier to read, and then pull out the things that are important. So the scenario is that unfinished material consists of steel fabricated products of various forms, and they come in, they're called black materials. This raw material is delivered to Goronwy on large trailers in bundles. Those bundles are referred to as batches. You'll notice that every business will have its own language in which they use to speak about certain things. And so as an analyst, you are going to have to understand their language, because bundles here mean something different to somewhere else most likely. So on arrival at the galvanizing plant, the black material is unpacked by an inbound logistics operative and checked for discrepancies, like the material is not suitable for galvanizing. So there's a quality check. If it's good, there's a decision point. You can see the if there, the question. So if it's good, the products are galvanized and left to dry. Once it's been galvanized, we refer to those things as white material. So the white material is then checked, and any unsatisfactory white material is re-galvanized. We just put it through the process again. Is there another decision point there? Yeah, we have to make a choice about this. Satisfactory white material is bundled on trailers and dispatched back to the customer. So in this case, this comment says the customer is the same customer as the one who gave us the black material. That's how I would read that. Does that make sense too? Now, if that's not clear, you should clarify that, because is that important? Yeah, absolutely. It's going to be important. The activity system is shown in the figure on the next page. There's some dotted lines indicating the precedence of each activity in the system. So let's have a look at it. I'm just going to go to the diagram, so it's bigger, and we can have a look at it. So where would we start with this kind of diagram? What do you think? Possibly top left. Hopefully it's been drawn in a way that makes sense. That isn't always the case. We will probably start with one of the actors. So let's start with the actor on the top left and see how we go. So the customer over here has some black material, and Goronwy is the white box, and they receive the black material. This dotted line here shows the sequence. So we're going to go from here to here with our black material for checking. Once we get in this one, you'll see that there's a square around this, a box, and that's just to show this is actually one process. It just has multiple parts to it. Right? The parts are, well, check it. What does checking involve? Well, we look at it to see if it's satisfactory. Is it satisfactory? If the answer is no, then we return, we have a process for this, and the black material goes back to the customer. Can you see how that follows? So it's fairly simple modeling, and we don't have much detail about the actual process. We just know what kind of happens in this situation. Once we've checked the black material, right, and it's satisfactory, we want to galvanize the material. Now, when we galvanize material, do we need the black material? Yes. So you can see this arrow shows that the black material is processed and put towards this galvanizing process. Once it's been galvanized, we have the galvanized material, and then there's another one of these call-out boxes. We check it. Here it goes. Is it satisfactory? If it's no, we go back and we galvanize it again. If it is satisfactory, we rebundle it, because we had to unbundle it to do the galvanizing. So now we rebundle it, we dispatch it, and the white material goes out to the customer. Can you see that even with very, very simple modeling, like boxes and squares and things and diamonds, you can make fairly complex decision trees in this? Yeah? You can actually build up quite complex things. So not having access to all the other BPMN stuff isn't actually really a problem for us at this point. Right? So we can work around that limitation. So here's the simpler one, a nicer looking one, which doesn't use the standard symbols. So what you can see is the customer, now it looks like a Lego dude, and they have some black material, and it doesn't look like black material to me, but I guess that may not be the right picture. And there's a delivery note. So this one has extra information. What's the extra information? The delivery note, right? We're now also modeling the flow of information between these things. Because what happens is, well, in the previous diagram, black material just shows up on the door, right? Do they tell you what's coming? Most likely. They send you an email or something, and they have a note saying, look, we've got 20 of these things, go and galvanize them for us. And that's now captured in this delivery note. You'll see then there's a job sheet created with the checked material. We're not modeling that the material is returned if it's bad. We could do that, but it's not our concern here. And we galvanize it. The completed job sheet, when it's done, the galvanized material, is it satisfactory? This is part of our process, so yes, we model that. If it's not satisfactory, we re-galvanize it. Eventually it goes to a truck, and the white material goes back to the customer with a dispatch note saying, you sent us 20 things, 2 of them were bad, so we didn't do those, 18 of them were good, so we did those, and here's the 18. And this is what it's going to cost, right? Does this diagram have a different purpose to the previous one? Yeah. So depending on what we're trying to model, we will use slightly different notation. Now we just go through a little bit. I'm not going to spend a lot of time on this, but basically this system, it was a paper-based system. There's lots of these notes, and you'll see basically that's a little problematic. So they had a manual information system, relied on the flow of documents to inform the coordination of the activity. The delivery advice note supplied with the product has an advice number for that manufacturer, so every manufacturer has a different number. Each batch is identified on the delivery advice note by an order number. This document would accompany the physical delivery of the black goods. Basically it says, you got this many of this kind, this many of this kind, this is how much they weigh, that information. Okay, so that's fine. Then after checking, the details from the delivery advice notice are transcribed by the production control and a clerk by hand to a job sheet. That sounds problematic to me. Yeah, it sounds like there could be a lot of easy mistakes made there. Okay, and it's paper-based, so papers can get lost. Separate job sheet is filled in for each order line on the delivery advice note and is passed down to the shop floor of the factory to the foreman. Again, it's manual, so lots of opportunity for things to go wrong here, right? And there's some information here. When the shop floor has treated a series of jobs, a dispatch advice note is issued. Each trailer for dispatch will have an associated dispatch advice note detailing what the white material is on the trailer. Because there are discrepancies, and remember you can send some of this material back or it isn't, galvanized properly or whatever, so there might be a discrepancy or a partial dispatch for one job. So the whole job hasn't been done. So you have multiple pieces of paper which you need to put together to get a true reflection of what actually happened. Can you see that there might be some problems with this kind of approach? At least it's pretty easy, to lose a piece of paper or to make a mistake somewhere. So this might be a good example of where an information system actually would be pretty good. You type in once, and everyone has access to the digital version, yeah, and so they just use that one. There's a lot less of this passing things around. So here's the entire information flow through the system. Again, I'm not going to spend a lot of time on this, but I will just talk through it, just to show you the difference here, right? So before, this was a much simpler diagram. Now there's a lot more stuff going on. Is it still the same thing? Well, sort of. Customer's still here. They have black material. You receive black material. There's a delivery note. Now there's information. This dotted line is still here saying we're going to take the black material for checking. We check it. Is the material satisfactory? No, you get it back, right, with this black material. Yes. Well, we're going to galvanize the material. What material? Well, that material that you gave us. And we give the material there. We check the white material. Is it satisfactory? No. We go back and do this again and again until it is. If it is satisfactory, we create a dispatch advice, dispatch note. This is a database of some kind, or a data store where we can store this information. And there's a completed job sheet which goes to this process called update job sheet, which goes into a job sheet data store. When eventually there's a dispatch note, or there's a rebundle in dispatch, there's a dispatch note and the material goes out here. And there's also some information about creating a job sheet and storing it somewhere and using that in this process. Did it get a lot more complicated? Absolutely. Right now it's actually, I think, more difficult to think about. But you can see it captures the process, or the different parts of the process, with both physical material and the information. Now we don't always do that. Sometimes we're only interested in the physical stuff. We saw some diagrams like that. Sometimes we're only interested in the information stuff. Right? So we're just worried about the information flows. We don't care at all about the physical stuff moving around. So they are different types of models. One of them is a physical type model, and one of them is an information systems model. And we'll talk about that in detail later on too. So there's boxes, connecting lines, there's symbols, and in other courses you'll learn some different kinds of notation for different kinds of modeling. This course we're just going to look at the BPMN and a couple of other types which we'll talk about later. I do want to show you just really quickly, this is an information model that you might use for databases, for example. Does this look like the one we just drew before? No, it's different, has a different purpose. This is not in this course, by the way. I'll just point that out really clearly. It's not taught in this course, it's not assessed, but you will see this kind of diagram, and it's just another way to model some information. And this thing might say, for example, look, here's a product in the middle, and the product may appear on 0 or more order lines. So we're not finished yet, guys, so can you please just hold on for a second? So this one tells you more information about how many times something appears, for example. Okay, and that could be useful in certain context. But like I said, this diagram in particular is not part of the course. I just wanted to show you because you will see things like this, and it's useful to know where they fit. They have a different purpose. Okay, so that's the end of this section.